In this video we have a look at the new automaton model, and the new automaton model are the non-deterministic finite automata. Short NFAs. We've already seen deterministic, and now we'll have non-deterministic finite automata. And to start with, we start with a challenge. Assume you are working for a company using some kind of internet addresses. In these internet addresses, in these domain names, you would like to check whether the domain name is actually a German domain. So checking for .de domains. So we have an input string, and we'd like to check whether this input string actually ends in .de if it's a German domain name. That doesn't sound that complicated. However, problem. Remember, we are passing the string from left to right. So once we've seen .de, we are not ready yet, because there's something like, for example, www.debian.org. That's for sure not a DE domain, so it's not a German domain, but we still have this substring .de. And that's something that makes it more complicated for a deterministic automaton. Now at this point, just try for yourself to devise a deterministic finite automaton to just check these domain names, whether it's a DE domain or not, whether it's a German domain or not. Just try. And if you have done so, you might have realized that it's really complicated. You have a lot of states, a lot of things to consider. But it could be much easier if we would be allowed to guess. So DFA is complicated. If we were allowed to guess, we could just do something like this. We have an initial state, and then we have letters A to Z. And if we see a dot, we change state. If we see another dot, if we see a D, we change state again. And if we see an E, and stop here, then we would be accepting. If after the dot, we could go back with A to Z. So actually, this automaton is able to guess. And the guessing actually happens here. After seeing a dot, we can guess whether we take this D transition or whether we take this D transition. The D is in this A to Z expression, it's included. So with the D, at this point, we could go either back to the initial state or forward if we have guessed that this is the end of the string. So much easier with guessing. So if you compare this automaton with the automaton you might have drawn, you will probably realize that this one is much easier. So this is NFA. This is a so-called non-deterministic automaton because it can actually guess. It can go either way. We can go back to the initial state, back to the next state. And this thing is easier because of guessing. And actually these non-deterministic automata, they have a lot of cool features. So the cool features are, first, This is something you don't see here yet in this example, but this will be very useful later on. We have a set of initial states. So the non-deterministic automaton has already a non-determinism in the beginning, so it can choose where to start. So we might have more than one initial state. And we have 0 or more successor states. For each state. There's something you see here. Here we have 2. In this state, for example, there's no successor for, let's say, D. If we would be here with the D, there's no outgoing transition with the D, so it would be stuck. So it's possible to have 0 successor states for a given letter. And what the automaton does is it guesses. So this thing can guess which transition to take. And the good thing is, it is always right. So it will always guess the right transition. If you are uncomfortable with the idea of guessing, we can do it a bit more formally and say, if there is a way to an accepting state, it will find it. So finds an accepting run if there's one. Accepting run if there's one. So that's actually the idea of an NFA. The NFA, they have some pros and some cons. The pro is that it's simple. In many cases, it's a simple and small automaton compared to a DFA. And it allows for simple constructions. That's something we'll see in later videos, that with the NFA we can do a lot of constructions quite easily. So allows for easy constructions. However, there's also a con, and the con is we cannot implement it on a deterministic computer. The thing that it's allowed to guess, that's really hard to implement. So the con is guessing is hard to implement in hardware software.